Hi, Mr. Pepperell here, and in this little video I'm going to talk to you about series circuits, and more precisely, how does connecting the components of a circuit in series affect the properties of the circuit, like its current, potential difference and the resistance. Now, there aren't any equations for this little video here, but you are going to make a little note of the various rules that I discussed with you.
So, previously we found out a bit about the potential difference in current and resistance in a circuit. Now we need to think about a couple of different types of circuits and how the type of circuit actually affects these measurements. And first up is, as I've got here, series circuits. Okay, so looking at this circuit that I've got drawn here for you, this is what we call a series circuit. All of the components, the cell, the bulb, the next bulb and the switch, all of the components are in this circuit are connected one after another in a straight line. So, we've got the cell there, we go follow the wire around, we get to the bulb in a straight line, we come to the next bulb, okay, in a straight line, although this is actually, not straight in the diagram, they are one after another till we get to the switch and back to the cell again. Okay, so these components are basically in a straight line with each other, just like episodes in a TV series, hence the name. Okay, so first of all, I want to think about in terms of, well, what are the properties of this circuit? I want to have a quick think about current in series circuits. Well, in the case of this circuit here, the current flowing through these components is exactly the same through each individual component. So if I look at this bulb here, okay, and I say that the current is 5 amps there, okay, the current's going to be 5 amps through that bulb, the current's going to be 5 amps through the switch, the current's going to be 5 amps through the cell. Okay, so the same current passes through components in series with one another. So that's the first rule that we need to think about, is the fact that the same current passes through components in series with one another. So we can see that there, we've got 5 amps here, 5 amps here. It's going to be 5 amps through every single component in that circuit. Okay, so that's the first rule you need to make a little note about. So that's current, but what about potential difference or voltage in a series circuit? So if we look at the same circuit that we had before, okay, the electrons that are passing through each bulb in the circuit are being pushed around this circuit by the cell. That's its job up here. Okay, now the potential difference or voltage of this cell is actually a measure of the energy that's transferred from the cell by each electron that passes through it. So each electron that passes through it transfers a certain amount of energy, okay, and that's what the potential difference is a measure of. Since each one of these electrons then passes through this bulb and then that bulb, the amount of energy it gets up here, or the potential difference up here, is shared between the two bulbs. So if the potential difference of this cell was 12 volts up there, okay, the potential difference across each bulb will be 6 volts across this bulb, 6 volts across this bulb, and you can see that 6 volts plus 6 volts is going to be equal to 12 volts across there. So the rule here is the total potential difference of the voltage supply in a series circuit is shared between the components. Okay, so that's our rule for voltage in series circuits. So that's a little bit about potential difference in a series circuit, but what happens if there's actually more than one cell connected in series, like I've got on here? Okay, well, providing each cell is connected in the same direction, and by that I mean from positive to negative, positive to negative, positive to negative, like I've got on here, okay? Each cell in the circuit gives the electrons, so imagine there's an electron coming through here along the circuit, he gets to the first cell, gives him a push. This cell gives it a push, this cell gives it a push, gives it a push, and it goes off around the circuit, okay? Each cell gives the electron a little push, so an electron would get the same push from a single cell, if it was 6 volts, as if there were a battery, and by that I mean more than one cell, of little 1.5 volt cells. So all of these here, 1.5, 1.5, 1.5, 1.5, that all adds up to 6 volts. So the electron will get a total push of 6 volts from the cell, the same as it would do from 4 individual 1.5 volt cells. Okay, so in other words, what I'm saying here is that the total potential difference of cells in series is the sum of the potential difference of each cell. Okay, we can see that having 4 1.5 volt cells would be exactly the same as having one 6 volt cell. The last thing I want to think about is, what about the resistance of components in a series circuit? Well, it's a similar rule to what we just talked about with the cells, to be honest. If you have two components in a circuit like this, and for example, this bulb here might have a resistance of 5 ohms, this bulb here might have a resistance of 4 ohms. Well, if you have two components which both have different resistance, then the total resistance of the circuit, if they're connected in series, is the sum of the two. So in this case, we're going to have a total resistance of 4 plus 5 ohms is going to be equal to 9 ohms is the total resistance in that circuit. Okay, so basically what I'm saying is the total resistance of components in series is equal to the sum of the resistance of each component. Okay, that's the final rule we need to think about. So to sort of sum up everything we've just said here, let's just go back over those rules again. Say I want to think about the current in this circuit. Well, if I measure the current here and I get a current of 5 amps through that bulb, the current is the same no matter where I measure it in the circuit. It's the same current through every component. So that means there's going to be a current of 5 amps through both bulbs, a current of 5 amps through the switch, and a current of 5 amps through the cell. What about potential difference in the circuit? Well, if I've got a cell up here with a potential difference of 12 volts, that means that that potential difference is going to be shared across the components in the circuit. Okay, so the potential difference across this is going to be 6 volts across here, it's going to be 6 volts across here as well. Okay, so the potential difference is shared about in the circuit. Up here I could have a 12 volt power supply, or I could also have a 6 volt plus 6 volt, two different cells up here. They'd have exactly the same effect. Okay, and finally, if I worked out that the resistance of this bulb was 4 ohms and the resistance of this bulb was 6 ohms, then the total resistance in my circuit is going to be 6 plus 4 is going to be equal to 10 ohms. So that's all the rules we need to know about for series circuit.
So they are the rules we need to know about for components in a series circuit. Any problems with that, don't hesitate to tweet me at Mr_Pepperell on Twitter and I'll get back to you straight away. Thanks for stopping by.